So in this lab, we will use convolutional neural networks for image classification. And I prepared 6 questions in this notebook. So there's a brief review of AutoGrad because we will examine it very briefly in this lab notebook. That is one of the first question to ask you. So then we move on to the image classification task. We will use the very popular CIFAR10 dataset. This is to import all the necessary libraries. And we will load CIFAR10 first, right? So using PyTorch building functions. Here, the data will be downloaded, right? So if you haven't done before, it will be downloaded in a directory called, in your local directory of this notebook called data, right? So the data, the CIFAR10 will be downloaded under this directory. So because it's quite large, so I did not put under the data set and it's not uploaded, right? It's not uploaded to GitHub because it's quite big. So when you run this code, right? So when you run this code, the data set will be automatically downloaded to this directory. And in the future, when you run it again, right? So it will not download. You don't need to change this to false because it will automatically check, right? So you don't have to change it to false after your first download. You just keep it true. It will be fine, right? So I have, you see, this file already, right? So this is because I run it multiple times. So it will say, okay, it's already downloaded and verified. And so there will be no just key, it will not just download and replace, right? So this is my explanation, right? So, and you can take a look at the training set and the test set. And here also shows you how you can display some of the images. Right? So this data set is very small. Each image is also only has a size of 32 by 32. This is exactly the size we used in the lecture, right? So in the last session. But you can still recognize, for example, this is a cat and this is a dog. This may be a bird. This is a trunk, something like that. Yeah. You have the. You can also print the label, right? So this is a trunk, bird, cat, and dog, right? So you can. It's very small, right? So and then the next step, right? So is to define the architecture of the CNN, right? So here are some. This is the net, right? So the net, and I think that's what we are going to build, right? So that's the net, and we are. This is some help you to review some of the convolution layers, right? So how to do convolution, and you can do some computation, right? So you can do some computation to verify how you do convolution, right? And this is a question to ask you about the convolution, right? So you can try to do manual computation of the convolution value output. This is for multiple channel, multiple output channel, and then here, right? So here is some inspection, right? So inspection of your image, right? Inspection of the image. This is a convolution layer that you defined. The number of input channel, output channel, and size of the kernel. Right? So that is convolutional layer, right? So it is trying to explore the convolution layer, and then you explore the pooling layer, which is a kind of subsampling. This max pooling we see in the lecture. And you should notice that max pooling has no trainable parameter, right? Because you are just taking the max, right? So there's no trainable parameter, right? You are not learning anything over here, right? So, but there's a hyperparameter, which is the future size, right? So whether it's 2 by 2 or 3 by 3 and stride, right? So there are the hyperparameters, but there's no parameter to learn, right? So if you examine the parameter, actually it's empty, right? There's nothing to learn over here, right? So here is the CNN architecture, which is actually I think it's a LANET, right? It's LANET, and this is a common flow where you see this is the first is number of input channel, second parameter is number of output channel, and third one is a kernel size. So that is kernel size. And this explains this architecture, right? Convolution 1, convolution 2. Right, so this is an explanation, right? So you should be able to figure out, right? So the size at each layer, right? So I have give you detailed explanation, right? So over here, please read through it and make sure you understand. If we change it, right, so you can still figure it out. And here, I indeed ask you a question. I ask you a question over here. Please answer it. And here's some inspection of the parameters, right, of the number of parameters in the convolution layer, as it consists of weights and of the bias, right, of the bias. You can see here actually is actual values. Initial value, I think it's learned or initial. That's still the initial, right? So it's the initialized value for your bias. And then here ask you a question, right? Please answer. Then what following is to define the metric or the loss, which is here we use cross entropy and the optimizer using SGD. And these are parameters for SGD. And then we will train the network, right? Train the network. Here we use just a 2 epoch, right? We just use 2 epochs. And this can take a while, right? This can take a while, depend on how fast is your computer, right? So it can take a while, but it's not terribly long. It maybe take about around a few minutes, right? So, but you can see the output, right? So as long as you see your there's something coming out, you know it's running, right? So it's running. It will take a few minutes on my laptop, right? A few minutes, maybe up to 10 minutes, right? So just be patient to wait for it to finish. And then you can also take a look at the autograph, how they keep track, right? So this is the next function, and you can see this it is negative log likelihood, backward, this is softmax, backward, and so on. Right? So you keep track of the functions. And then we save the model and then load the model for prediction. Right? So it's more like a testing mode, right? Testing mode. Right? So and is another question, right? So this is basically in my case I got 53, right? So 53%, and typically you should get accuracy around 50, right? Around 50. If it's not 50, around 50, something is wrong, right? Something is wrong. And this is a final question, and you can examine the accuracy for individual classes, right? So here are some for those who really have interest, right? So there are lots of things you can manipulate and change, right? Change the loss function, and if you have GPU, right, so you can try GPU to be very fast, right? So the training will be very fast if you use GPU, right? But how to do it, you can look at the PyTorch tutorial. Okay, so that is a lab, right? So it's quite involved, and the training will take a while, maybe 10 minutes or so or more. But it's still bearable, right? So our assignment, I think we will set questions on this notebook, right? So that's all. So this week we cover the convolutional neural networks, and in the lab you will use it for image classification. So I'll stop here, and I'll see you next week. Bye bye.